here is the question. Question is will be discussed the four things. Year by year, the data's needs is the very highly increasing, such as we use the YouTubers and videos and very big internet data systems. So the in overcome this kind of the problem increasing datas, there are several methods to overcoming, such as the single mode fibers and optical fibers amplifiers. We discussed the open doped fiber amplifiers, and the last thing is the WDM, such as the wavelength division multiplexing system, is the key photonic components and devices. So I think that these three things is the more detailedly we can discuss. This is the concept of the optical communication. Here is the single mode fibers transmission modes is the figures, and O band and E band and S band and C band, L band is the widely used because of the optical communication. And single mode fibers in this region are very low absorption, and this is the peak is the OH minus absorption water peak. So we can make a single mode very high beam qualities and very low attenuation, so we can make a very longer distance transmitters using single mode fiber. And this is the picture of the wavelength division multiplexing system. And here is the number of the transmitters, which is the individual different wavelengths, and the wavelengths difference of the signals propagated optical fiber. And here is the C band amplifier, and L band amplifiers will be amplifying these signals, and optical fibers and amplifiers and repeat this process, and finally they reach the receiver, several the receivers, which is the each individual signals, and will be more high information increasing. And here is the open doped fiber amplifier system structures. And here is the pump lasers. We use the usually 980 nanometers, and the pump laser will be pumping in the open doped fibers. And here is the isolators. Isolators low is the determine the direction. So the signals is the comes in the open doped fiber lasers, and the amplifier signals is comes out. So this is the concept. And I will discuss more practical example by using our laboratory. I use the C and L band lasers, as you can see, like this. And this is the SMF, the single mode fiber structures. So here is the core and the cladding, and this is the plastic jacket, the coating. So the experimental setup is the C band and the L band lasers, and this laser signal is the propagated single mode fiber, and last we detect the equipment's name is the optical spectrum analyzers. So as you can see in the wavelength domain, the black one is the C band lasers, and red one is the L band lasers. So this laser is the difference of the wavelength domain, but the most lowest absorption band. And this is the wavelength domain and intensity domain, so we can analyze the how intensity in the wavelength domains. And I gonna show you open doped fibers amplifiers using this C band lasers is the comes in the open doped fiber amplifiers, and analyze this OSA. So this is the experimental setup. This black line is the open doped fiber amplifiers. The open doped amplifiers shape is the like hat, and if we signal in the C-band lasers blue one throughout the EDFA, the data is red one like this. So the signal and lasers is more amplifying previous one. And one thing is the wavelength multiplexing system is the control the wavelengths is the most important thing is and I use the open loop fiber amplifiers and through the bandwidth tunable filters and analyze this OSA. So the bandwidth, the variable tunable filters picture is like this, so that I can control the bandwidth and wavelengths as well. So here is the result. I use the open loop fiber lasers, open loop fiber amplifiers, like shape of the head, and I can control the bandwidth control like this. And if we control the bandwidth more broad, more shorter like this, and I select the one bandwidth, and I can control the also wavelength controls as well. So the shape is the following open loop fibers and different wavelengths. We can make it very easily. But the optical communication limit in the capacitor crunch overcome, we can make more option is in here. But the same thing is the if the individual signals, we can make transmitters, and individual signal is the propagated optical fibers, and finally individual signals we can detect using receivers. So the individual signals is the more increasing data's capacities. So the this is the main principle of the overcome this kind of the problem. So here is I gonna show you the space division multiplexing system is to make a multi-core fiber is in here. The several multi-core fibers is the specially like this, and we can make a signal individually and propagated in the multi-core fiber system, and the detector is like this. So this multiplexing is also make a very integrated system like this using silicon chip. This is very small size of the chip, and propagated also multi-core fiber system, and receiver is also compact system using this integrated integration system. And one thing is the mode division multiplexing, which is the if the multi-core fibers propagation of the light is the make a many kind of the mode, such as the LP1 mode, LP2 mode like this, because of the Helmholtz equations. And this individual mode is the filling to different effective refractive index in the optical fibers. So the optical fibers mode is divided by because of this kind of the mode. And last thing is the recent research area is the optical angular momentum systems using like make a hollow optical fibers cores, and this vortex beam is the will be more one of the option of the this kind of the capacitor crunch. I'm gonna show you some conference name is the optical networking and communication conference, one of the biggest optical fiber conference called OFC. There are 3 researchers is the plenary speakers, and here is the 3 titles plenary speakers. One thing is the 5G. 5G is the very well-known concept of the communication system, nowadays in the Korea. And one thing is the gravitational wave detecting using the interferometers, the neutron stars pulsar. And last thing is the optical materials. If some next materials compared to the silicas is the very big issue to optical communication system, I think. So here is the my final presentation, and thank you for your watching, and have a good day. Thank you.